So let's continue. So let's continue to study partial fraction. So okay, we already talked about the case 1. Now let's talk about case 2. So we assume that Qx can be written as A1x plus B1 and R1, AKX plus BK and RK. So if you recall case 1, for the R1, no, if you recall case 1, it means that R1 equals to R2 equals to RK and equals to 1. But for case 2, the R1 is greater or equal to 1, or RK is greater than equal to 1. So means that, it contains a factor AIXBI. The power it can at least contain 1 XI BI for which the power Ri is greater than 1. If all Ri is equal to 1, that's case 1. So if Qx can be written as this format, we have Qx can be written as first, for the first is A1x plus B1 and A1 1 plus A1 R1 A1x plus B1 R1. Okay. Plus A21 A1 X A2 plus B2 continue plus A2 R2 A2 X plus B2 R2. So we continue this process. We have AK1 AKX plus BK plus AK RK over AKX plus BK and RK. So if you look at the textbook just write one term, right? So anyway, it seems what I wrote here gives you more information, but they're equivalent to each other. Okay, just look at an example. You have to know how to do an example. That's the essential part. So let's look at example 4. Example 4. So we have x power 24 minus 2x squared plus 4x plus 1 over x cubic minus x squared minus x plus 1 dx. So if you look at this and rational function, right? If you check the degree, you can say px is equal to x power 24 minus 2x squared plus 4x plus 1. Qx is x cubic minus x squared minus x plus 1. So the degree of px is 4. The degree of qx is 3, right? So we have the degree of px is greater than the degree of qx. So means that this rational function is improper. right? Not proper. But like what I said before, whenever you are using the partial fraction, your rational function has to be proper. So you have to use a long division. Okay, and by long division, we have x power to 4 minus 2x squared plus 4x plus 1 is over x cubic minus x squared minus x plus 1 is x plus 1 and plus 4x over x cubic minus x squared minus x plus 1. Right here, by long division, you have to calculate this by yourself. So I will not repeat this. You studied this in your high school, and also I already give you an example. If you look at the last video, right? So you have to practice this. Because in the test, if a problem like this, you have to kind of split this rational function into two parts, polynomial and proper function, a rational function. Okay, so do this by yourself. Okay, so let's continue. So we have x minus 4x x cubic minus x squared minus x plus 1 dx is x plus 1 plus 4x over x cubic minus x squared minus x plus 1 dx. And then we have this is half x squared plus x plus 4x over x cubic minus x squared minus x plus 1 dx. So now we have to deal with this term. Right? So how? So let's look at the denominator. So for the denominator, we have x cubic minus x squared minus x plus 1. So which is, x squared, x minus 1 minus x minus 1. So this is x minus 1, x squared minus 1. So this is x minus 1 times by x plus 1, x minus 1. So this is equal to x minus 1 complete squared multiplied by x plus 1. So we have 4x by x cubic minus x squared plus minus x plus 1 is 4x over x minus 1 cubic and x plus 1. Right? By what I said, look at the left hand side. We have this is, no, sorry, I made a mistake. So I have erased something. So not 4. So we have this is x minus 1. Okay, a plus b x minus 1 complete square and plus c over x plus 1. Right? So the next, whenever we write our proper rational function in this format, the next step is to find a, so let's write it on. So find a, b, c, right? So let's multiply by this term on both sides. So we have 4x equals to ax minus 1 plus b, right? Plus c. Oh, sorry, I made a mistake, I think. Anyway, this term, this method is very simple. Ax minus 1 x plus 1 and plus b x plus 1 plus c and x minus 1 complete square, right? So, and then we simplify the right hand side. I think it's quite easy. This is a plus c complete square plus b minus 2c x plus negative a plus b plus c. Okay, for this term, so let's continue to compute ABC. So let me change the color. So I want to finish this problem in one page. Okay, so we have a plus c is 0, b minus 2c is 0, b plus c minus a is, this is 4, sorry. This is 0. So solving this by solving the linear equations, we have a is 1, b is positive 2, c is negative 1. Okay, so you have to solve it by yourself. Solve it by yourself. I think you studied this in your high school, right? I cannot, present everything for you. You have to solve it by yourself. Okay. Okay. So let's continue. So we have the integral 4x dx over x cubic minus x squared plus minus x plus 1 is, okay, the first term is this plus 2x minus 1 complete square dx plus c is negative 1, right? And x plus 1 dx. So let's compute the answer. The first term is ln x minus 1. The second term is x minus 1, right? And the third term is negative ln x plus 1, right? So let's combine all terms. Okay. So let me change the color. So let's continue to this place. Okay. So we have this x squared power to 4 minus x squared plus 4x plus 1 over x cubic minus x squared minus x 1 plus 1 dx is equals to half x squared plus x. I just copy these two terms and then we combine these two terms together. So it's plus ln absolute value x minus 1 plus x plus 1 minus half. Here I forgot other c, and x minus 1 and plus c. Okay. Anyway, the textbook use k. I don't know why. Sometimes the textbook always made a mistake, right? In general, the people just use c. I don't think the book is not wrong, but we just use c. Okay. So this is our example for the case 2. So that's very important. Okay. So and then let's continue. So next page. So let me change the color. Okay. So let's look at case 3. So what's case 3? So case 3 is okay. So let's look at case 3. For case 3 means that the QX contains a irreducible quadratic factors. Okay, but they are not repeated. So let me give you an example. If you look at the English, sometimes it cannot convey it clearly. For example, like a QX contains like this. So X squared minus 2X plus, for example, 3. This is an irreducible quadratic form. You may ask why, how do you know it? Right, here you have to check this delta, which is b squared minus 4ac. If this is less than 0, so it means that qx is irreducible. So you may say, I don't know what's irreducible. Irreducible means that qx cannot be written as a1x b1 a2x plus b2. It cannot write as a product of two linear factors. Okay, so qx can be like a x squared minus 2x plus 3 like this, or multiplied by some q1x. But I said they are not repeated, means that qx cannot write as like some power, right? q1x, qr cannot be a number greater than 1. So means that it only has one factor like this. Okay, but you may say, if the power for an irreducible quadratic polynomial, the power is greater than 1, what happened? That's not our case. We are talking about this kind of problem case by case. So this is our this case. So if like this, how do we do it? So let me look at an example. Okay, let's look at example. Example 5. So this is 2x squared minus x plus 4 over x cubic plus 4x dx. So if first step 1, you check right directly, I will not repeat, write px, qx, and then check the degree. This is obvious, right? This function fx equals to 2x squared minus x plus 4 and x cubic plus 4x is proper, right? Right. So it's proper. So, and then let's look at the qx. Qx is x cubic plus 4x, which is x, right? Times x squared plus 4, right? We know this is irreducible, right? The power is 1. So by this, so we can, by this method, we can have fx equals to 2x squared minus x plus 1 over x cubic plus 4x, which is 2x squared minus x plus 1. So this is x and x squared plus 4. Okay, kind of this is a good example. And then, so by this case, so let's look at this, because I didn't tell you, okay, if qx like this, how can we use the partial fraction? If like this, let's go this place. So this is px over qx. If like this, so means that you write this in the format of partial fraction. It has to, for example, here we write qx. Qx is contains ax squared plus bx plus c, right? By this term, by this we have, this can be written as ax plus b over x squared plus bx plus c and plus something else. Because I didn't write outside, right? Let's look at examples in them. I don't require to remember all the abstract formula, but you have to learn everything by examples. If you can do examples, you know, I think you can do every problem. If you look at the following, you know, example, like step 2 here. So it contains x and x squared plus 4. So this is reducible. This is a linear factor. By the method, we have this is x, okay, a plus, like what I said before. So we have one term is x squared plus 4, and the numerator is is bx plus c. But you may ask me, this is different from the above x squared plus bx plus c. No, they are the same. B just 0. Okay, and then so let's multiply by x times x squared plus 4. We have, okay, 2x squared minus x plus 1 is equals to a plus b x squared plus cx plus 4a. So we have a plus b is 2, c is -1, 4a is 1. So we have a is 1. Oh, sorry, 4a is 4. No, 4a is 4. I think I made some mistake here. You know, this is 4. This is 4. So this is 4. B is 1. C is -1. So let's come back. Come back to the integral. So we call this is step 3. So we have x squared minus x plus 4 over x cubic plus 4x dx is, this is 1 over x plus x minus 1 x squared plus 4 dx. So this is 1 over x dx plus x minus 1 x squared plus 4 dx, right? For the first term, it's quite, you know, easy to find the antiderivative. This is ln x, right? How about the second term, you know, x squared plus 4 dx, right? So let's compute the second term, x minus 1 and dx x squared plus 4. This is x over x squared plus 4 dx minus dx over x squared plus 4, right? So let's compute the first term. Okay. So we have two integrals, right? So let's compute this x squared plus 4 dx, right? How do you do this? We set u is x squared plus 4. So we have du is 2x, right? By this, we have this is half du over u, right? We have half ln u absolute value plus c. So this is half ln x squared plus 4. So we don't have to write absolute value here, sign here, because it's positive, and plus c. So this is the first term. Let's look at the second term. I don't write this minus here. I just compute the dx over x squared plus 4. So what's this? Here you have to remember a formula. That's very important. So dx over x squared plus a squared, and a is greater than 0. You have to remember this. This is 1 over a tangenta, the inverse function, and x over a plus c. So by this formula, you have to remember this. Remember this. That's the basic formula. So we have this is 1 over 2, right? And tangenta negative half x plus c. So now we combine everything together. So let's change the color here. Okay. So we combine everything here. This is ln x absolute value, right? plus, yes, and half ln x squared plus 4, right? I will not write say here because there are many sets, right? Plus half tangent elective half x plus c. So let me label it. So this, you know, this is this term, this is this term, right? Anyway, the computation is quite clear. So this is our final answer for case 3. Okay. Let me save it. Okay. So let me give you one more example. Okay. Let me change the color. Okay. Example 6. So this example is 4x squared minus 3x plus 2 over 4x squared minus 4x plus 3 dx. So first you have to know if the function is proper or improper. So step 1, you can say, so f(x) equals to 4x squared minus 3x plus 2, and 4x squared minus 4x plus 3 is improper. So if it is improper, what we do? So we have to use the long division. So 4x squared minus 3x plus 2 over 4x squared minus 4x plus 3 is 1 plus x minus 1 over 4x squared minus 4x plus 3. Okay. And then, so now check this. Of course, it's proper, right? That's our goal. This is a proper function. Okay. For this proper rational function, so we can check. So qx is 4x squared minus 4x dx, right? Delta is b squared minus 4ac. So this is 16 minus 4 multiplied by 4 minus 3. Of course, this is less than 0. So we get qx is irreducible, right? So we have this is an irreducible. Wait for a moment. I forget the spelling. It's normal, right? Irreducible. So it's irreducible. That's our case 3, right? So let's continue. So for this, so let's just, we have, sorry, it's not right. I should not write this here. So we have x minus 1 over 4x squared minus 4x plus 3, right? By this, how do we do it, right? This is already an irreducible function, right? So let me say this is x minus 1 over, if you look at this, this is 4x squared minus 4x plus 1 and then plus 2. So this is x minus 1 and 2x minus 1 complete squared, right? This is a common trick, whenever, we know this, I think in high school, ax plus bx plus c, this can be written as candle something like, s squared. Candle like a and x plus k squared plus h, right? That's we studied in maybe middle school, right? So by this, so we have to compute this. So let's do it. Okay. So we have to compute this plus 2, 4x squared minus 4x plus 3 dx. So this is 1 dx plus x minus 1, 2x minus 1 complete square plus 2 dx. So how do we do this? Okay, let's compute the first term. This is x plus 2x minus 1 complete square plus 2. Right, I think my computation is right. So what do we do next? So I forgot the dx. So next step. So this is step 1. So this is step 2, like that. So let's deal with the second term. Let's deal with this term. So how do we compute this 2x minus 1 complete square and plus 2, right? So to be honest, there are many ways to compute this integral. So let's use the u substitution. Here we set u is 2x minus 1. So we have du is 2dx. Okay, and we, but here you have to, think it a little bit. So here you can say we said u is 2x, but here there is no 2x, right? Here we have a common tree. So we have right x has 2x and then minus 1. Okay. Oh, you don't have to try this method. Okay. This is the method used in the textbook, but maybe I think it's hard for you. Let me, pretend we don't know. The following method is a universal method. We solve x. So x is u plus 1 over 2, right? We use the u substitution. So, and dx is half du. So let's compute x minus 1 dx over 2x minus 1 squared plus 2. So let's plug in this. This is half u plus 1 minus 1 and du. After here, dx is half du. Okay, over u squared plus 2. So let's simplify it. So let's simplify. This is quarter u minus 1 and u squared plus 2 and du. So let's continue, right? This is half and u squared plus 2 du plus quarter negative 1 u squared plus 2 du. For the first term, if you look at this term is the same as this term, right? The formula is the same. I didn't say this is 2, right? But this is not 4. You by the same method, you say that u is something, you can get this is 1 over 8 ln. You say that u is v. No, you said u squared plus 2 is v. And okay, that here, how do we do this term? And set v is u squared plus 2. So, and then you will get this is u squared plus 2. And for this term, this is minus this 1 over u squared plus square root complete squared du, right? So, and then this is 1 over 8 ln u squared plus 2, right? And then here, just formula, right? Minus half 1 over square root of 2, no, tangent negative x over square root of 2 plus c. So, and then let's combine together, we will get the final solution. Okay, I think that's this problem because, you may not see my screen because like what I said before, the university probably pay less, and then after I record maybe 40 minutes, and then you cannot see a screen. Okay,